Okay, so now that we've found the invariant, so x less than or equal to a and x is equal to 3d, now we have to actually prove this property here, where log is this entire program above. So how do we prove this statement? So the first thing we do, proving something in whole logic, is we prove this triple first. So the invariant and the loop condition, then the body, which is the stuff inside the while loop, and then the invariant. So if we can prove this, then we can use the while rule, and then we can precondition strengthen, post-condition weaken as required. So let's write our goal statement. So we want invariant, and the statement B, which is the loop condition, 3x is less than a, the body, which is these two statements here. That should have a semicolon. And then the post condition, which is again the invariant. And perhaps when you do this for the exam, you may want to also type it down because it's easier to copy paste statements rather than writing out a whole bunch of stuff. So how am I going to prove this? Well, we're going to have to use sequencing. So I'll copy up post condition, and then I'll copy up the second bit of code. And then I have to work out what statement would go here to make this a valid instance of the assignment rule. So I guess we replace all the x's with x times 3's, and now it becomes very clear why we want to do this on the computer. Okay, so that's true by the assignment rule. And then I want to copy up this statement here, and the precondition from below, and the first piece of code, which is d equals d plus 1. And somehow I have to prove this line here. How do I do that? Well, I copy up the post condition in the piece of code, and then do the assignment rule backwards like I usually do. So what would have to be on the left-hand side for this to be true? I guess you replace d's with d's plus 1's, like that. And now I have to somehow get from this line here to this line here. So hopefully this stuff here is a stronger statement. Is that necessarily true? Let's sanity test ourselves by bashing. So let's sanity test ourselves. We want to check that this is true. So I want that if x is less than or equal to a, and x equals 3 to the d, and 3 times x is strictly less than a, then it follows that x times 3 is less than or equal to a, and x times 3 is 3 to the d plus 1. If we take this statement, multiply both sides by 3, the statement immediately follows. And this statement here is just a weaker form of this one above, so that indeed checks out, and this is indeed a true statement by logic. So this is true by logic. This was an assignment. This would be precondition strengthening from the first two lines. So at this point now I guess I got to give things line numbers. So that's line 1, line 2, line 3, 4 and 5. So precondition strengthening 1 and 2. That was an assignment. And then 5 is we're sequencing the two parts together. So we sequence 3 and 4 together. Cool. So now I've got a statement of the form I and B, the body of the code I. Well, now I can use the while rule. So I can replace this with I, which is my invariant, while B, do the code. So I'm just going to replace that with, what was it called? Log was the name of the entire program. Oh, no, have I lied? Yep, that's fine. Log is the entire program. Cool. Log, and then so I, while B, do S, I and not B. So invariant, and the loop condition is false. And that's our loop condition. I'm using exclamation mark here for, whoops, using exclamation mark here for false. So while 5. And what I actually want is this statement here. So now I have to do some precondition strengthening, post-condition weakening. So hopefully this thing implies my precondition above, which is just the invariant. So let's check that out, see if that's legit. So we need, if d is 0 and x is 1 and a is bigger than 0, that implies x is less than or equal to a and x equals 3 to the d. Well, if x is 1 and a is strictly greater than 0, then that's the same thing as saying a is greater than or equal to 1, which means x is greater than or equal to a. That checks out. And if x is 1 and d is 0, well, clearly 1 equals 3 to the 0, so that checks out as well. Cool. All right, so that's all good. So this is true by math or logic or whatever you want to write, which means we can take this statement above and swap in the precondition through laborious use of copy-paste. So precondition strengthening, 6 and 7. And then I need this thing to imply the post condition that I want. So we want, this statement here to imply my desired post condition. Is that true? Let's go back to our drawing board. So we want x less than or equal to a and x equals 3 to the d. And it's false to say 3x strictly less than a, which is the same thing as saying 3x is greater than 3 equal to a. And what do we want? We want 3 to the d is less than or equal to a, which follows immediately, right? We've got x is less than or equal to a, x equals 3 to the d, so these two facts together give us 3 to the d is less than or equal to a. Cool, so that checks out. So that's true by math, logic, whatever. And then we can take this statement here and weaken the post condition by replacing it with this weaker statement. Post con weak, lines 8 and 9. And that looks like the desired statement.